Okay, for each function, state the maximum number of turns the graph could make. List the x-intercepts where the graph crosses the x-axis and the x-intercepts that do not cross the x-axis, and then sketch the graph. This sounds more complicated than it is, so let's go ahead and get started. So for this first one, state the maximum number of turns the graph could make. You're just going to look at the highest degree and one less than that. It'll make 2 turns. A cubic makes 2 turns. So let me show you what I mean by that. So notice here we have an x squared. Well, an x squared is a parabola. Oh, look at 1 turn. 1 is 1 less than 2. A cubic, 2 turns. 2 is 1 less than 3. A quartic, x to the 4th. 1, 2, 3 turns. 3 is less than 1. So that's all it's talking about. So for this, there will be 3 turns at the most. All right? The next thing, you need to find the x-intercepts. So remember, that's about factoring. So notice, what do x cubed, 2x squared, negative 2x squared, and x have in common? An x, which will leave x squared minus 2x plus 1. Don't forget the plus 1. Don't put a 0 there. X divided by x, they both have each other in common with a 1 being left in its place. And then we've got this basic quadratic. So we have the x's go here. Factors of 1 that add up to negative 2. Well, that would be negative 1 and negative 1. Negative 1 times negative 1 multiplies to be positive 1, and negative 1 plus negative 1 adds up to negative 2. And this means the same thing as negative 1 squared. So to find our x-intercepts, we set each one equal to 0. X equals 0, and then x minus 1 squared equal to 0. Well, the easy way to do it is just, well, if there's an x on the outside of parentheses, that automatically equals 0. And then whatever 0 is out inside, the opposite of negative 1 is positive 1. But there's a multiplicity of 2. And remember what we talked about before. Whenever you have a binomial of multiplicity of 2, when you're graphing, that's where it's going to sit on the x-axis. So we know, do this, x is equal to 0. We know it'll cross right there at 0. And then where x is equal to 1, it's going to sit right there on the x-axis. And then remember, this is a cubic. A cubic looks something like this. So I'm going to guess it's probably looking something like this. I don't know how close I am. You could throw it into Desmos, but it's going to look something like that. Notice the x crosses where x is equal to 0, but it doesn't cross the x-axis where x is equal to 1. This next one's going to be a little bit trickier. It's a negative. That means, remember, it's going to be upside down. And x to the 4th, meaning there'll be 3, at most 3 curves. And all 4 terms have an x in common. They all have a negative sign in front. So look at what I did. I factored out a negative 1x, and that left 1x cubed plus 6x squared plus 12x plus 8. And to find the roots, we're going to go ahead and do synthetic division. So we bring down the 1, the 6, the 12, and the 8. Remember from our couple weeks ago when we were studying those 3 theorems, rational root theorem, we would take factors of 8, 1, 2, 4, and 8, both positive and negative, divided by the factors of the lead coefficient, which is 1. 8 is the constant, 1 is the lead coefficient. But the other, if you look at Descartes, remember Descartes' rule of sign? All of these are positive, so there will be 0 possible positive real roots. So the only things we need to try are the negative numbers. So I'm going to start with, I'm going to try -2. So -2 times 1 is -2. 6 plus -2 is +4. -2 times 4 is -8. 12 plus -8 is 4. -2 times 4 is -8. So we know that not only is x is equal to 0 because this x factored out, but now we have x is equal to -2. But look at what we're left with. 1, 4, 4. I'm going to try -2 again. So we bring down the 1, and then 1 times -2 is -2. 4 plus -2 is 2. -2 times 2 is -4. -2 worked again, and then look at how odd that will be. -2 is going to work a third time. So we have -2 multiplicity of 2. Now this is why this one was important for you to go over. On this last problem, where it was a cubic and one of the zeros was an x is equal to 0, what that left with, when you have x is equal to 0, that leaves an x squared. Well, an x squared is a parabola. So when we have a multiplicity of 2, we have a parabola. But over here, whoops, we have a multiplicity of 3. 1, 2, 3. Well, that's a cubic. So that means there will be a cubic shape where x is equal to -2. So we know that we have x is equal to 0 and x is equal to -2, but this multiplicity of 3 tells us there will be a cubic shape where x is equal to 2. So I'm going to do something like, whoops. I'm going to do something like that. I don't know if that's perfect. And then it also touches at 0. I'm going to maybe draw that a little bit better. I am not doing this very well. There we go. So here's our 1, 2, 3 turns. Here's our cubic shape right there. So it's going to look something like that. It might be a little bit higher up here. You'll have to check Desmos. But that's pretty much it. When it's state the maximum number of zeros. Oh, so we need to list everything. So the maximum number of turns is 3. The maximum number of turns is 3. That's 1 less than 4. And look at x crosses the x-axis in 2 places. There's none that just sit there. So x crosses where x is equal to 0 and where x is equal to -2. All right.